Yeah, thank you for the introduction. My name is Malte Ostendorff, and I'm presenting our paper evaluating document representations for content-based legal literature recommendations. And this is a joint work with Elliot Ash, Terry Ruers, Bela Gibb, Julia Moreno-Schneider, and Georg Rehm. In this research, we explore how state-of-the-art document representation techniques perform in the context of a legal document recommender system. So why did we conduct this research? Literature recommender systems help legal professionals to find relevant literature, and they are getting more and more important as more and more literature is getting available. And in the recent year, there have been much progress in the technologies that underpin recommender systems, mostly based on deep learning approaches like transformer models or graph embeddings. So the question is whether these improvements are also beneficial in the context of a legal recommender system. Besides the technical aspect, we conduct this research also with reproducibility in mind. In general, recommender system research is known to have a reproducibility issue. And this issue also exists for legal recommender systems, where evaluations are often based on a small-scale user study, and also the evaluation data is rarely published. And this leads to inconsistent research results and makes it very difficult to actually reproduce the research. And that's why we set ourselves the following two research objectives. First, we want to evaluate a large variety of state-of-the-art methods. And second, we want to use publicly available data sets so we can make our work reproducible. This brings us to the data sets that we use in our experiments. We have three main criteria for the data set. That is an open license that allows us to share the data without any restrictions. And the data set should be also sufficiently large and also reflect different information needs. The large coverage of the data set is especially important when we want to compare fundamentally different methods like text-based against citation-based methods. We found two resources that fulfill these criteria, namely that is Open Casebooks and Wikisource. Open Casebooks is a platform from the Harvard Law School library where users can create and share open license casebooks. Their corpus consists of around 200 casebooks containing 3,000 cases. And the casebooks cover broad topics, but also rather specific ones. The cases from Open Casebooks are linked to the Case Law Access project. So based on this, we can retrieve full text and also the citation data for all the cases. After some cleaning procedure, we end up with relevance annotations for 1,601 court decisions for this data set. Our second data set is Wikisource. Here we utilize a collection of around 3,000 US Supreme Court decisions from Wikisource. Wikisource is a project like Wikipedia from the Wikimedia Foundations, and they collect original source documents. And this collection we are looking at is a collection of court decisions that is categorized in 67 topics, rather broad topics like antitrust or civil rights. A source for the full text and citations, we map the court decisions to the court listener corpus to have all the data available. And here, as a result, we have relevance annotation for 1,363 court decisions. But how do we derive relevance annotations from these data sets? In our experiments, we are considering a recommender scenario where we have a seed document and we want to know which other document would be a relevant recommendation for the seed. So as ground truth data, we need pairs of documents that are relevant for each other. And the two data sets provide exactly this information. For example, when decision A and B are in the same casebook or in the same wiki source category, we can say that A is relevant for B and vice versa. This relevance definition is, of course, limited. For example, one recommendation still might be relevant despite not being in the same casebook or category. That's why we rather refer to these data sets as silver standards instead of gold standards. However, the advantage is that this approach produces a large number of relevance annotation for open casebooks. It's 140,000 document pairs, and for Wikisource, it's 200,000 document pairs. And this number is much larger compared to the user studies from related work. And it also enables us to evaluate a large number of methods. In total, we evaluate 41 methods and variations of them, and which 27 are actually presented in the paper. The remaining ones were excluded due to either poor performance or because they didn't provide any additional insights. The methods themselves, we distinguish them in 5 categories. First, we have a TF-IDF baseline. Second, we have word vector-based methods like paragraph vectors or document vectors from averaged word vectors from fast text or GLAF. This is also known as mean pooling of word vectors. And here we test also different variations. One is kind of the original version of GLAF or of fast text trained on a generic text corpus. And also one version where we train the word vectors on our legal corpus. We also test variations with an artificial token limit to make these methods comparable to the transformer methods. As transformer methods, we have BERT, Roberta, different sentence transformer models. We have longformer and 2 separately published legal BERT versions. One from Chakalidis et al. From the Athens University of Economics and Business, AUEB, and one from Holzenberger et al. From the Johns Hopkins University, JHU. In addition to the citation text-based methods, we have text-based methods. Oh, sorry. In addition to the text-based methods, we have citation-based methods that utilize the citation graph to derive document embeddings. And lastly, we have hybrid methods that make use of both text and citation features. There is one approach that is the concatenation of document vectors from 2 methods. And also we have the score summation of similarity scores from 2 different methods. And as another hybrid method, we have a sentence transformer model that we train with citations as training signal. Before I dive into the actual results, some more words on our evaluation methodology. We separately evaluate open casebooks and Wikisource. And each of the tested methods here produces document vectors for all documents in the corpus. And then based on the vector representations, we then perform a k-nearest neighbor search to retrieve 5 most similar documents, which are then used as recommendations. For the evaluation, we then compare the seed document and the recommendation candidate with our silver standards to determine whether it is a relevant recommendation or not. As a performance measure, here we have precision, recall, mean reciprocal rank, and our primary metric is mean average precision. Just as a side note, we set K to 5 because of the user interface where we want to deploy our recommender system. we also experimented with different K values, but found the results to be similar. All right, so let's start with the actual results. In this table, we have the tested systems, the dimension of their vector representations, and then the performance matrix for open casebooks and Wikisource. And we have the rank that's based on the average MIP over the two data sets. And this is also how the rows are ordered in this table. And also in this presentation, I will now only show parts of the actual table. So please look into our paper for the full version of it. On average, we have the hybrid score summation of fast-text legal. So that's the fast-text word vectors trained on our corpus, and the citation graph embeddings from PointCare, and they together have the highest MIP score. But if we view the data set separately, we have a slightly different outcome for open casebooks. It is the text-only method fast-text legal that yields the highest MIP, whereas for Wikisource, it's another hybrid method, the concatenation of fast-text legal and PointCare that yields the highest MIP. The other domain-specific word vectors like paragraph vectors or glove legal are also among the top methods. On the lower end of our table, we have the worst performing methods, which are sentence transformer models like Sentence Roberta or the citation method BoostNE. Now, for more insights, let's look at the method categories separately. Here in this table, we see all the word vector-based methods that we evaluated. At the top, again, we have the domain-specific word vectors that utilize the full article text. We see that also limiting the document text to a length that can be processed by the transformers does harm the performance, as we can see here with fast-text legal limited to either 4096 tokens or to 512 tokens. The other domain-specific methods like paragraph vectors or glove legal have shown a similar decline when limiting their document length, but are not listed here in the paper. But more important than the token limit is the in-domain pre-training of the underlying word vectors. As we can see here with the original glove and fast-text, those kind of generic word vectors were trained on Wikipedia or news text, so nothing was legal. As third category, we have our transformer models. And yeah, despite being very successful for many NLP tasks, one major weakness of transformers is that they are made to process relatively short text. So for example, in BERT, the limit is 512 tokens. In Longformer, it is 4096 tokens. And in our experiments, we have legal documents that are typically longer. So here we only can process the first n tokens of the documents that fit into the corresponding transformer model. And that's, of course, one limitation here of the transformer models. And to make the results comparable, at the top here, we have the legal, fast-text legal version, where we have the similar limited token number. And exactly these two fast-text legal variations are also on average better than all other transformer models. Whereby for open casebooks, the token limit has a stronger effect on the performance. Here we have Longformer large, the best transformer model, and it also outperforms the 512 token version of fast-text legal. For the other data set, for Wikisource, the token limit is less critical. Instead, the in-domain pre-training has a greater effect. So here we have the two legal BERT versions are the best transformer models. And generally, we found that from the two legal BERT versions, the one from AOEB outperforms the one from JHU. And we see this reason for this outcome in a larger and more diverse pre-training corpus that was used from the one from AOEB. Similarly, we see that among all transformer models, the large version outperformed the base version. For example, here, Longformer or BERT. But yeah, overall, the performance of the transformers is relatively low. But one could expect that there might be a performance gain when, for example, you would train a Longformer model on a legal corpora. Yet these potential performance gains will most likely not justify the computational effort, in particular when we already have very simple and yet effective methods like averaging word vectors. And this is also what we found when we analyzed how the performance changes depending on the length of the seed documents. And there we found that even for short documents, FastText Legal outperformed all the transformer models. In addition to the text-based approaches, we also evaluate citation graph embeddings. And in this category, we have a SPAT method, point care, closely followed by walklets. And overall here, we found that there's a strong dependency on the availability of citations. And that's why we say, or we suggest that these citation methods are actually better combined with text-based methods. And this is exactly also what our evaluation of the hybrid methods show. Here as hybrid methods, we focus on the combination of the previous best single methods, which are FastText Legal and point care. Other combinations like glove and walklets have shown a similar performance, but they're excluded because they didn't provide any additional insights. The best methods in this category are also the best methods overall, and that is the score summation of FastText Legal and point care. And again, here we also see a difference between the performance of open casebooks and Wikisource. While for open casebooks, the score summation is the best hybrid methods. For Wikisource, it is the concatenation of FastText Legal and point care. Other combinations, especially the one from two text-based methods, like here FastText Legal with Longformer, do not lead to the same performance gains as the combination of text and citation-based methods. And why the combination of text and citation improved the results is clear when we now have a look at the similarity of the recommendation sets. In this heat map, you can see the Jacquard similarity of the recommendations of two methods, where Jacquard similarity of 1 means that all recommendations are identical, and 0 means no overlapping recommendations. And what you can see here is a higher similarity between the text-based methods and also between the citation-based methods. But when you compare the similarity between text or word vector methods and citation methods, the similarity is low. So this means that they produce a different kind of recommendations. And this is also why combining them in a hybrid manner leads to this performance improvement. All right, so what conclusions can we draw from our experiments? First of all, document vectors from averaged word vectors achieved surprisingly the best results. for all single methods. In particular, fast text word vectors trained on our legal corpus performed the best on both data sets. The training of such word vectors does also not require any special hardware like GPUs. And even when we introduced this artificial token limit, the performance of FastText Legal was still comparable high. On the contrary, we have the performance from the transformer model that were rather disappointing. Of course, we have the weakness of the token limit, which is especially a problem when we have lengthy documents like these court decisions. And of course, there are promising research efforts like the longformer that are capable of processing more tokens. However, right now, training such a model and especially applying it in a production environment requires much more compute resources. And these potential performance gains do not really justify these efforts. Much less effort actually does it take to combine text and citation methods in a hybrid manner. In our experiments, we use very simple approaches like the concatenation of vectors or just adding up similarity scores, and still outperformed all other single methods. Lastly, we also validated our quantitative findings based on the two silver standards with a domain expert who agreed in 70% with our silver standards. And this high agreement and also the large quantity of the two data sets makes them very interesting for future work, where we plan to use them to benchmark also new different document representation methods. All right, thank you very much. Please feel welcome to look at our code and dataset. It's all available on GitHub. Yeah, thank you very much.
Thank you, Malte. And now I have some comments and questions here. I'm going to read for you, okay?
Sure.
First, from Sabine Wenhart. I just have a comment that I don't agree with your formulation of recommending legal literature. You did legal document recommendation. Legal literature shall refer to educational textbooks in law. Reading your presentation's title, I expect a different word, but still, I think what you did is impressive. Okay, you want to say something about that?
Yeah, of course. I mean, the term literature covers a lot, right? And in our example, we mostly focus on, or only focus on court decisions. So of course, this is kind of a subset of all literature, and I agree. Yeah, would be interesting to expand this to other educational textbooks. This might be also something for future work.
And here we have a comment and a question from Trevor Benchcapel. These results all look pretty poor with less than 0.6 for precision and very low recall. Are these techniques useful at all? Even the best is not good.
Yeah, that's actually the generally low scores due to the silver standards that we used. I mentioned that this is also the reason why we refer to them as silver standards, not as gold standard, but because we expected that many actually relevant recommendations will be missed by our ground truth, by the silver standards. And this is also what we found in the kind of expert study, where we had one domain expert judging the recommendations. And there we also found that relevant recommendations were missed, right? Where the domain expert said, okay, this would be relevant for me, but it was not part of the silver standard. And this is how kind of I would explain the low results. And kind of this is of course one weakness from the silver standard, but I see kind of the big advantage opposed to maybe a user study that is typically conducted, is that we have a much bigger quantity of actually recommendation pairs that we can compare. And this is also what we did in the paper. It's not really now presented in the slides, but kind of we also checked how the actual performance is changing when depending on like document characteristics like the document length or citation count, which I would say to do something like this, you need, I don't know, a bigger evaluation corpus, which usually like a user study wouldn't provide. And, so this is kind of the, yeah, on one hand, like one weakness of our silver standard, but also one strength, right? That we, it's difficult, yeah, to you have to low results, but on the other hand, you can perform more analysis on the data because you have more quantity.
Right. And we have a question here from Winkles. Perhaps users might find recommendation useful. Nevertheless.
Yeah, so maybe just as an outlook, so kind of what we did here was really just evaluating a lot of existing methods to have already kind of a limited subset of methods that we now, in the next step, want to evaluate in an actual live system, right? You probably can't really run like A/B testing on those 40 methods or something that we tested. So at first, we want to select a subset and then now compare the most promising methods in a more detailed study with real users.
I have a comment from Adam Weiner. I agree with Red Bull. It's very useful and important to have studies like this that reproduce, evaluate, and compare results. Okay. You want to say something?
Yeah, thanks. I agree. So that's kind of okay. the motivation behind it. That yeah, we found okay, many existing work use user studies, but that's kind of difficult to reproduce, and that's why we thought okay to have these kind of openly available data sets. And now we can kind of continue working with these data sets and also then go and actually improve the methods for these data sets.
All right. And I have a question from Dennis Miller. Did you investigate how the results change with large K? Given the relatively close results, do they exhibit similar performance for more recommendations?
Actually, with larger K, the scores increase slightly, but of course, as you get to very large K, where they stop to kind of decline again. But yeah, as I mentioned, kind of this setting K to 5 was mainly chosen because kind of the service where we want to deploy this recommender system has kind of this restriction of just showing the top 5 recommendations in the user interface, and this was kind of the reason why we then in the end decided to just stick to this one K value.
Okay. So we have.
But yeah, sorry, kind of the second question was right if the actually relative results changed, but no. So kind of the ranking among the methods, especially among the top methods, it didn't change.
Okay. And so we have just 3 minutes left. If you want to make some final remarks, make yourself comfortable.
Yeah, maybe yes. Actually, if there is somebody who also runs like a recommender system in a production environment and wants to actually test kind of all the methods in a, I don't know, A/B test or something, of course, we are always looking for kind of partners who have access to such a system to run these experiments with real users. So yeah, I'm happy if there's somebody and yeah, who would be interested in doing such an experiment together with us.
I have a first question by Marcelo Lopez, and it's the following question. Is there any special reason why you chose Open Casebook and Wiksource as sources for the documents? I noticed that many methods work better on one source than another. Why do you think this happened?
Yeah, thank you for the question. So first of all, we mainly choose these two data sets, not really because of their documents, but rather because of their relevance annotations. So we could use them actually to evaluate the methods, because they had kind of this topic assignments or those casebook assignments. That was kind of the main reason for us to use these two data sets. And then regarding that we have on Wikisource kind of better scores. And this is due to, I think, two things I would say. One is that Wikisource is only about US Supreme Court decisions, where they also cover a relatively broad topics, right? It's kind of a special type of documents, and there's not too much diversity in those documents. And this is the other reason it's probably now more important, is that kind of on average, we have for each C document more relevant annotations in Wikisource than in casebooks. So just in theory, there are more potentially relevant recommendations. And yeah, this is why we see this outcome.
Thank you, Mr. Ostendorff. I have another question, and it's the following. In your paper, the documents evaluated were legal documents, such as court decisions. If we were to adapt the system to work on education and scholarly literature, what changes would be necessary?
Yeah, thank you again. Basically nothing. So the methods that we used are kind of used in an unsupervised or zero-shot setting. So we don't actually train the models on our evaluation data. So if you now just want to apply these methods on a new corpus, you just need to have basically the text input, and then can derive based from the method or based on the methods your document vectors, and then kind of perform your similarity search on these vectors. So the input is basically text, and yeah, the output are these vectors. So you don't need to do anything else. Well, of course, kind of if you want to evaluate this on a different corpus, which probably makes sense before you want to apply it, then you of course need to have some kind of additional data to measure how good the methods are on your data set.
All right, thank you, Mr. Ostendorff. Is there any further point you'd like to address or any comments you'd like to make?
Just a part of thanking you for this opportunity to present the paper here. Yeah, nothing. So thanks again.